Yo, what's going on, guys? Welcome back to this NeuroEvolution of Augmenting Topologies code along. Now, I know it's been a year, but we're finally back, and hopefully we'll continue this up to speciation, crossover, and everything else that was in the scene before. But today we're not going to do too much. We're gonna kind of just get back into it with saving of networks. So let's open up the scene first and get started with that. Now, before our version was at 2020.2.1 F1, but now our version I had to upgrade to 2021.1.20 because of some issue with Linux. If you guys don't have to upgrade, then don't do it. But if you do have to upgrade to the same one that I went to. The way to do that is you go to installs and you go to add and you add the one that you need to add, right? The one I told you about over there. I believe you can go back to for older ones from here. So install that. Install version 2021. One second, sorry, getting a phone call already. Oh my god. Okay, version 2021.1.20 F1, and then we can get started. When you click it, it's going to ask you that it's a newer version, so just say yes, and you'll be good to go. Just say yes. Alright. So it's been quite a while, and actually, these videos haven't gotten a lot of views, but the community base that is coming off these videos, it's pretty cool to see. People are very nice. They're writing really long comments and saying how these videos are helping. I appreciate that, and that's why I'm continuing with some more videos. So, all right, let's see where we left off. And one more thing that's different. I'm not on Linux for this. I moved to Windows because I was having some issues with Unity in Linux. And you guys might not have that issue if you're on that, but in Windows this works fine. Just import your project and you'll be good to go. Let's get going. It's been quite some time. Just speed up to 5. Let's see what's going on. So we have our genetic manager right here that lets us know the current alive, the current generation, the starting population, and we can change some of the stuff from here, the starting population, and so on, right? But one problem we have is that whenever we stop the Unity game, we lose our networks, right? The best fishes, what's the point of having these networks if you can't move them anywhere, do anything else with them, right? It's cool in the game, but if let's say you have another problem, you make a scene that's similar in Python. Well, if you match the parameters of this to the Python scene, as in the values you get from the raycasts and everything, then you could just import this network into that. But more so, saving networks helps you because then you can just save the best ones you see and keep generating more really good networks that are slightly different, and then in the future you can upload all your best networks in a game or something that you're making. So saving, I think, is really important, and that's what we'll cover today. Saving and loading. And then after this, I know everybody wants to see speciation. So it will be saving, loading, and then I plan to do speciation, and then I plan to do the visualization of the network. Now, maybe I'll switch the visualization of the network with the speciation. We'll see how that goes. Alright, let's get started. Now, to start off, one of the things we're going to do, we go to the scripts, go to neat. We have all these scripts. I hope you guys have the same ones and you guys are following along. The last thing we did was change the genome, and we changed these numbers right here, the mutate genome numbers and the numbers for the protrusion and all that. And I'm happy with these numbers, so we'll stay here. What is this? Okay, I'm happy with all that, so we'll now be done with this script and create the new script that we need for our saving, which is going to be called NeuroEutilities. So just go to neat folder, create a new script, and call that NeuroEutilities. And I don't know, I might spell it wrong, but I'm not really that worried about spelling, as long as everything is lining up. Okay, now so this is just going to be a utility class, and this script will have serializable classes of the genome. So we're just going to get rid of this, and I'll explain what I mean by serializable classes of the genome. Ooh, sorry about that. Okay, let me press play here, make sure there's no errors. Perfect. I was getting a weird error in Linux whenever I created a new script, and I think that's because of the .NET issue. And if you guys are having a blank error, that if you ever have a blank error and you don't know what the heck is going on, you go to console, you go to you right-click console, and you click open editor log, and this will give you a little bit more information about errors. But usually you won't have to do that, and if it scares you, don't worry. It very, very rarely will you have to go into that. Okay, but that's just a little tip on debugging. Now that we have this, let me explain to you guys what I mean by having a serializable genome class within this. So our neat genome is set up with 3 different classes, right? We have the class for the connection genes, which are our edges in our neural network, our input node, our output node. So our connection gene holds the information about the input node and the output node, the weight of the edge, if the edge is active or not, and the innovation number of the edge. So innovation numbers are important because it comes into speciation in the future, but we'll get to that. Now, our node genes contain information of the ID of the node and the type of node it is. So our node genes contain the information of ID and whether it's a hidden node, output node, input node, right? And now both of these end up being tied together through our neat genome, which holds a list of our node genes and our connection genes, right? So this is all the information you need to build a network. And this is kind of like the DNA for your neural networks. Each of your neural network has a genome. This is a recap, by the way, guys. I've already covered this, but just going over some of the stuff. Each of your genome contains all the information needed to build your network. It's kind of like the DNA, right? Your network is the brain that ends up, after it is built, passing the information you get from your environment. Now, we also have a body. Your network is placed within, your network is placed within the body object, which is each individual fish. So each individual fish has a body, it has eyes, which are the sensors, it has a brain, which is the neural network, and it has DNA, which is the neat genome. Alright, that's the recap of what the neat genome is. And so, to save a neural network, to save the brain of these fishes, what we need to do is save all the information that is stored in the neat genome. That means all of the nodes that are in there, all the connections, and the genome, And to do Well, and the reason why we don't just save these in like a text file is because we have a lot of functions here, right? And there's no easy way to simply take this and say, well, there is. Well, that's what we're going to do, but what we have to do is use a serializable class. And what that does is we create another class that just has this information. It doesn't have all of these classes, and we just copy over all the information from the genome we pass the function into the serializable neat genome class. And then we take that serializable class and we pass it to a function that converts it into a JSON file. And that JSON file is our save file. It's the text file. And that can be imported into Python to visualize the network. It could be imported into Unity to visualize the network. It could be imported into Unity to, say, load your networks, build networks from the same brain multiple times. There's a bunch of possibilities now that you have a text file of the brain. You could actually do things with it. So let's get started on that. And also, just to be very transparent, as always, I have reference code for myself. That is the code that I originally wrote for the scene that I showed in the beginning. And worst case scenario, if I don't finish this code along this time along, right? If I decide if it's like more than a month delay or something on the speciation, I'll just make that code public as well for you guys. But for right now, I don't want to make that code public because I'm using it for other projects. I would have to strip out a lot of the things that I'm doing with it. This code, however, completely public. You guys do whatever you guys want with it. I'm more than happy to share this with you guys. And in fact, I plan to share a lot of future stuff that is coming. As there's a lot of cool research that's happening, and hopefully, there's cool stuff coming. Just keep that in mind. Alright, so let's get started on this. And let me just make sure my OBS is properly recording. Yep, everything is looking good still. Okay. So for this, we're going to create a system dot spell it right, serializable. Yeah. System.serializable, and we're going to create a public class and call it. So what we need to do is create 3 of these system serializable classes, and each of them represent the 3 classes that I talked about earlier. So this one is going to be for the connection gene, and we're going to copy that over, connection gene, but we're going to call this connection gene JSON because these are going to be the classes that convert to JSON. And now, not that way. There we go. And now we're going to copy over the information we want to store. So we don't need this. Obviously, we don't need a constructor for this because we could have used a constructor, but we're just going to copy over the information. There's no reason to have that. Okay. And there are multiple better ways to do this, I'm sure, but this way for me was cleaner because I could really separate the functions for the connection genes and what's being saved. Alright, and now that we have everything for the connection gene, we're going to move on to making the class for the, and I'm just going to copy this, so, whatever, I'll just type it. This will be node gene JSON. Okay. And now that we have the node gene JSON, we need to copy over the information. And that should be good to go with that. I'm actually going to close this and close that here. Okay, now we do the last one we'll need, and we might actually add another one, but I'll explain that later. For right now, this will be the last one we need. Serializable, and now public class. And also, if you guys see this stuff, just auto. I just press tab to do the autocomplete on it. So that, and then genome Json. This is going to be the neat genome. Yeah. Let's just copy the same name so we keep it very clean. And now we need to copy over this information right here. Okay, from the neat genome, we copy over the node genes and the connection genes. Alright, so these are the three main classes we're going to need to hold the information for our list. But let's just initialize this real quick. New list, and this is going to be a new list of no gene Json. So that initializes that list, and so new list con Json. Alright, so both those are initialized, and so just to recap, what we did is we created serializable classes for the neat genome, the node gene, and the connection gene, named as con gene Json, node gene Json, neat genome Json, right? And then we simply copied over all of the public variables, all of the variables for them. We copied over these variables for the connection gene. We copied over these variables for the node gene. And then we copied over this for the neat genome, which is the list of the node genes and the connection genes, right? And if you wanted to change the name of this, you could to node genes Json, because that is actually what's happening. But I'll leave it. Man, okay, I can't leave it. Actually, it's fine. It's fine. Okay. Yeah. And the one thing different we did for this is we initialized the list instead of in the constructor. We just did it right here. Okay. Now let's go move into the actual save function. And give me 1 second. Alright, for the save function, we're going to create a public function within our neat utilities. So this function will be able to be called from within our neat genetic manager. The way we're going to do this is whenever one of our agents are able to survive up to a certain time, we're going to save them, right? And we're going to set that time as the best time. And we're going to set that time plus 50 as the best time. And then so on and so on. We're going to keep saving every 50, every time, like we're going to keep saving in 50 whatever time intervals, right? So It's not in seconds. I don't know what the time is in, but every 50 we're going to save, and that way if we reach like 1,000, we'll have the network that can go up to 1,000 time steps or whatever the time is. And that way we'll always have the best network saved. We won't lose any of the good networks. So let's get started on that. It's going to be a public function, static void, and it's going to be save genome. Okay, and for this we're going to pass it the neat genome. So this function will get the best genome, and then is going to convert all the information within the best genome to the serializable classes. So let's go ahead and create our genome class, our serializable neat genome. I'm just going to call it the genome Json class. So that will be neat genome Json, and we're going to call that genome Json equals new neat genome Json. That should be good there. Next, we're going to start copying over information of the nodes. So for each, and that's going to be node gene. In the genome that was passed, dot, what do we call that? So the neat genome, the node genes, the list that contains the node genes is right here. Or the node genes. And so let's start doing some debugging now. Console.log. We'll log each of the nodes just to see what's being printed. And we also need to call this function. So we'll go to our errors. Let's see what's going on. So the error is on 21. Yep, that is correct. That's a good catch. Compiler, good job, compiler. So that'll be that, and that will be that. Okay, so our list has to be of type node gene JSON and connection gene JSON, for it to initialize of those types. So just copy over this to here, this to here. Okay. Let's see, what else was there? Man, do I not remember how to print in Unity? Wow, it has been some time. Alright, cool. So I guess print or debug.log works. So print node. That should do that. Alright, cool. And now we need to be able to call the function. We still haven't called it anywhere. And in that, me just open the project. Alright, cool. So we're at the genetic manager, and here we will print. It has been a while. So we sort the population right here, right? And after we get the sorted population, that's when I want to do the print. Let me see. I don't remember if we import in Unity or not. Nah, it doesn't look like it. Nice. Okay, so whenever we sort the population, I want to see the information for the best one. That will be there we go. Details equals new utilities. Should be good to go right there, and then we do util dot save. What do we save with that? We're going to pass it the best network's genome. I believe each of our networks holds the genome. Yep, right there, my genome. Perfect. So we're going to do all networks. The first one dot my genome. That's what we're going to pass it, and hopefully this works. This is not in my reference code. Let me try something else then. Just call it like that, see if that works. Probably not. Definitely not. Doesn't matter. How? I'm going to change this up to 5. So it only happens once everybody dies. It happens on the repopulation. The sort. There we go. How does that? Okay. So since there's no let's analyze why this is the way it worked, not the other way. So the other way, this way, I'm initializing this, but there's no constructor or anything, so it doesn't. I'm assuming that's why. I don't know, and since it works, it works. I'm not gonna go too deep into it. Man, there was a time where I did know all this. It's just I haven't really messed with Unity in a long time. I've been messing a lot more with Vue and 3JS and stuff like that, but I know excuses still. Now let's move on from this. So we just have to call the neat utilities by the same name, and it gets to this, and then save genome. Okay. And then you pass in after the sorting, the best network is going to be at the top of our list. So we pass in the first one at the top of our list, the best network, and we grab its genome and pass it into save genome, and our save genome, not here, save genome gets it here and prints all of the nodes within it. Now that we know that that's working fine, let's start creating the save. Now we have to copy over all the information from the node genome to the serializable node genome Json. So the way we're going to do that is we create a new node gene Json object and call it node Json. Okay. Now we can populate these different things from within it. Specifically, we can populate the ID and the type. Let me just make sure both are public. They have to be because I copied it over, but still. So that will equal the node ID and then node JSON dot type. This is, we're going to cast the type, the node gene JSON dot type. There we go. And we're going to cast the type of the node. Right. So this gets the node dot type. Let me just make sure that is, yep. So this will get the node dot type, and then this will make sure that it's casted to the same thing as the node gene JSON type, which is this right here. Same thing, it just has to be casted for this class. Okay. And now that we have the node, all the information for the node populated, we can just do genome JSON dot node genes. So we're accessing the node gene list for the genome JSON object, and all we do is add the node JSON. Okay. And this way, this list is populated now with the information that we need. Alrighty. Now we're going to do the same thing for the edges. For each con gene, and then we'll call it con JSON. No, this is just the connection. So we're gonna for each connection gene within genome, so it's gonna be called connection. So con in genome dot, the name of this is congenes, and we know that is because it's right here. We copied it over. So let's go. We got the list for the genome's connections, and now we're going to copy over all the information. First, we have to create the class for each connection's connection gene JSON class. So con JSON, and then we'll call this con JSON equals new con JSON, right? And then con JSON, we're just going to copy over the input node, the output node, all the information we need. So that will be con JSON dot input node equals con dot input node con JSON dot output node equals con dot output node con JSON. Oh, yeah, con JSON dot. So it's input output weight equals con dot weight, and then con JSON dot is active equals con dot is active, and then con JSON dot innovation. This is pretty important to have, equals con dot node number. Alright, so that's good for populating, well, just copying over the information of the connection genes. But now we have to add this to our list. And we'll do that with genome JSON dot, and this is called congenes. Congenes dot add, and we're going to call this. I'm gonna add. Oh yeah, I'm trying not to copy paste JSON for you guys, so you guys can just see the typing happen, and it's a little bit slower. Yeah, I always get lost in all the copy and pasting in other tutorials, so hopefully it helps. I don't know. Alright, and now that that's done, we have our genome JSON object populated with all the information we need, and now we can do the saving. So what we're going to save it as is well, the way we're going to save it is string JSON. So we have to pass it. We have to convert this object into a string, a JSON string. JSON utility dot to JSON and genome JSON. All right. I think we're gonna have to import system and system.io, but let's see. So let's battle the errors now. Ha ha! Nice, no errors. Beautiful. Love to see it. But let's just make sure. Wait. I want to log this string. I'm gonna move the time up to 5. And oh yeah, to pull up this project settings time thing, you go to edit, you go to project settings, right? And in this you'll have a bunch of these. You go to time, and then you'll have this, and you can up the time scale to speed up your training and stuff, to see the simulation faster. There we go. So we have the printed information. However, our information for the connection genes doesn't seem to be in there. Okay, let's see what's going on with that. Because there's no way anything is moving without connection genes. Instead of printing this, let's print in here. And we'll print the con, so the connection gene. So no prints are coming out, meaning that it is not seeing the connection genes. So let's go see. It's called con genes. Let's take this print out from here and put it right at the top, and let's print the genome itself. This way we'll be able to see what's in the all the connections, anything that's in the genome itself. Oh, one more thing. Before I press play, I'm going to change the time scale to 20 so I don't have to keep changing it after I press play. It doesn't give me a detailed print of the object. So dot con genes. Okay. It might be an issue with our loop. I'm going to pull up this, print the listing entity. Let's copy that over. Okay, and our list is going to be genome.congenes. Ship printed. No prints. Interesting stuff. Interesting stuff indeed. Okay, I'm gonna let this play a little bit and just look through some of my other code and see if there's something in there that might kind of point us in the right direction. Okay. The only thing I can really see is that I'm using a function to get the connection genes in the actual code, but that shouldn't really affect this at all. By that I mean, over here I have a function. I might as well just write it real quick and see if that fixes the problem. So right here, I'm going to add a function called, and it's going to be public. It's going to return a list of con gene. And we're going to call it get con genes. And this is going to return the connection genes list. This really shouldn't do anything different. It'd be really weird if it does. Get con genes. And so we'll print out, we'll just see if it at all gets the connection genes from the genome. Nothing. How is that even possible? And the reason why this is very strange is because it does get the node genes just fine in the same way. So I'm going to remove this function, because that should not be the issue. Copy this, paste it into there, get rid of these, and completely delete this. So for right now, your code should look like this. Go ahead and pause and copy that over. And then over here, it should look like this. Go ahead, pause, copy that over. All right. get the print the size of this. So it's going to be genome.congenes.size. I believe that's the function. Okay, that is not the function. Let's see, size of list. A.count. Okay. Very interesting. So clearly, this genome that's being passed doesn't have connection genes. Let's see what's going on in our neat genetic manager. This might be a really good thing. Maybe there's a bug in here and we can solve it. So right here. Instead of this, we're going to do a print. We're going to print all networks 0.mygenome.connectiongenes.count. So let's see if it's actually 0. When we sort the population, let's see if it's actually 0. Capital C for the count. That's very interesting. The sorted one does seem to always have a 0 count. Why is that? So let's grab the last one on here and see what does that do. That would be 19. The question is, how does it only have 1? There's too much complex behavior here for just one node. Or for just one connection. But let's do like 10, somewhere in the middle. Yeah, okay, I got it. So what's actually happening is, for some reason, our sort seems to not be right. And this is a great find, because this is going to solve a lot of issues. Let's make sure what's going on, though. So we're going to print the networks, and we're going to go for the first one, .myFitness, or fitness. I want to see the fitness of that. That fitness should be the highest one. But I bet you it's going to give you 0s. Yep. Yeah, so clearly our fitness function, our sort population function is not right. And we're going to have to fix that. So now we're going to begin trying to fix the sort population function. And right now I'm just testing to see what's actually happening with our sort population. And we'll do that by printing each of the fitnesses as we go along. And we'll do that in here. So print, and we'll take this right here. So it's going to be all networks I dot fitness. Let's see, print. So everything's fitness is 0. Let's just keep going through it. What the heck is happening? Okay, I need to go to the network. Back to the genetic manager. The sort population happens before anything. I believe we also need to check the food controller real quick and see where the fitness is being set. So we're going to go to the food controller and go Control F, fitness. So on each fixed update, we calculate the fitness. We update the energy. We have the overall fitness. We have the overall fitness, but where are we setting the fitness of each network? That's what we need to see. Man, I'm pretty sure our fitness needs to be updated right here. So what we're going to do, let me just search this up real quick. Yeah, I don't see anywhere else where I'm setting the fitness. That's such a big oversight. That means no training has actually been happening. Well, there we go. So now over here, we're going to set the fitness for each of the networks. So my network dot. That's why it was looking like we were getting like randomly losing innovation. We were losing innovation. So my network.fitness equals overall fitness. And let's see if that fixes this issue. Still zeros across the board. Alright. So now what I want to actually test out then is, instead of having, we're going to first change the genetic manager to have only one. Starting population of just one. We're gonna not keep the best, and we're not gonna leave the worst. We're just gonna do 0, 0. That way we just have one agent that slowly tries to learn. Let me change the speed back down to 1. Now let's open up our genetic manager. And let's go down to where our print is happening for the fitness, and let's also print this, but not the genome. .congenes.count. Now, whenever we see movement, there has to be. Oh, yeah, that's true. Let's leave that, uncomment that, do a print here, and on networks, 0.my genome.congenes.count. So it does have connections and then mutating. A mutation, everything like that is right. It's our fitness that is the issue right now. So why is our fitness of each network not being set? Oh, okay, our fitness is being called when the death function gets called in our fish controller. So let me get rid of this again. Alright, we have our overall fitness and we call death. When death is called, passing the overall fitness. There's overall fitness, and overall fitness is public. Alright, so what we need to do when we press play, let it learn a little bit. And we'll go to 1, let it spin around a bit, and then go to 0. Yeah. 1. I want to grab it at the end of the simulation. So right about now. Okay, and now I want to go look at this fish clone and go look at the controller for it. Overall fitness is 0. If food multiplier is 0, what is it? Okay, so actually everything is being set fine. I think what's happening is that the multiplier that we have for the food is set for 0 on the fish prefab. So we open up the prefabs folder, click on fish, scroll down and set the food multiplier to 1. So we actually have some, because 0 multiplied by anything is 0. And over here, its food multiplier is being multiplied by food since start, so we're getting 0. Okay. Well, that's kind of weird that it was set to 0. I think this might be an import issue, but I'm not sure. If yours is set to 0, please set it to 2. I'm sorry about that. Okay. And now we press play. I don't think that fixed it. For some reason, our overall fitness still seems to be 0. And let me just make sure that is true. Go to the genetic manager and we'll get rid of this print right here. And it actually might be 0 because it's supposed to be 0 since it's not actually getting any food. But it just can't always be 0. So those were supposed to be 0s. I didn't see it getting any food. It did get food, and yeah, you see now you have 2s over there. When it does catch food, you have 2s and 4s and so on and so forth. So now everything is working fine. What a pain. The issue, since we did a lot of debugging, and I want to make sure that everybody is still with me, I'm sorry about that. But let's just go through the code and make sure nothing is broken. Okay? So your genetic manager, we kind of messed with the sort population function. It should look like this at this point. Okay? We don't need that. It should look like this at this point. Your need genome, we didn't mess with anything in here. We just looked at it. Everything should stay the same as it is. Your need utilities function, we just added a couple of prints here and there. So I'm just going to get rid of this print. I'm going to get rid of this print. And I'm just going to print the Json. So really you should be exactly where you were before we started this debugging. So if you want to go back before we did the debugging, that'd be good. I might add a little something pop up that says don't follow me along with this part of the code, so you don't have to like mess your code up. But I personally think the debugging process is one of the most important processes to understand this, right? So now we see that the fitness is being passed properly, all of that. So anyways, this is how your neat utilities function should look. Your fish controller, I did add something here, a line of code, but I removed it, and now it should all look the same. Right, it should look like this. And your genetic manager, yeah, we already covered that. Look like this. Cool. We should be caught up. Now that that's done, let's go to our genetic manager right here and change this back to 20. We're going to keep the best 3, and we're going to leave the worst 5. Okay, let's press play, and hopefully we should actually see better training. Yeah, we see like the same type of fish are being saved now, which is good. Yeah, this is looking a lot better. Man, this guy needs to go down. I need to see if this is working fine. So here we see some fish have fitnesses of 16, and those are the tops. And then we see it slowly declining, so it shows that our sorting function is working fine. We have some that are really bad, and then some doing really good. Let's make sure that's true again. Yep, and look, the top two made it to 778 and 280. So that's incredible. And once we have crossover and speciation, we're going to see a lot better results. All right. Now let's do what this whole video was about and do the saving. Let's get back to the saving. After we're done debugging, now we're going to call this function for the save genome function. We can go ahead and get rid of our controller, and we open our utilities. It should print the JSON file. And actually, I want to get rid of this print. I don't know where this print is coming from. Oh, I do know where that print is coming from. Let me get rid of that print, which should be right here. Alright, so in your genetic manager, just get rid of that print statement, and now we should be good to go. And let's see if the JSON files are properly being printed. And yeah, it should be the best. Yep, there we go. Now we have all of the information, the weights that is active, everything for the connection genes as well. Perfect, perfect. That was an interesting bug, but we fixed it, yeah. Okay, now where did my saving go? Alright, so we're passing in the best network right now. That's perfect. And to make sure, let's do fitness. Print the fitness, and it should be pretty high fitnesses as we see. Well, what's going on in the world today? Okay, and print on networks 0 fitness. That one has 6. This one should be higher than that. 32, perfect. Oh, we lost it. Still, if they hit the wall, they're going to lose their. They're not going to get far. This one should be really high. Yep, 100. Perfect. So it's working fine. Now that we can get rid of this print statement right here, and our save is working. We're good to go on that. Perfect, perfect, perfect. Well, not our save yet. We're getting the JSON string. Now we have to continue the save. So once we have the, let's open the neat utilities folder. Once we have the JSON string, we need to write it to a file. So it's going to be file dot write all, write all text. And this will be application dot data path. So the path of our application plus, and we're going to save this as save.txt. You can save it as whatever name you want. It's going to be the JSON object. And there we go. That should be perfect. Now this, when we call it, file does not exist in the current context. So let's import what we need to import for this to work. I believe for file we need to use system. .io. There we go. So we have to do using system.io to get the file path. But there we go. So we get file.write, and it should write it. Let's try. I want to get a couple of connection genes. Okay, perfect. Let's close it. And now we should have a file that is going to be that represents our save file. Right, and I believe I have to open that up. It's going to be here, right here. There we go. So within your assets folder, another save will, within your asset folders, there'll be a text file called save. You click that, and that shows you that string that was printed. This is all the information, one big long line of information for your network. This is basically your DNA written into a text file for each network. All right, perfect. So that's our save function, but now we're also going to need a load function. And this is where things get interesting. I might break this video apart here and do the load afterwards, but it's going to get done today. I'm going to do it right now. I just might break these videos into multiple parts.